Okay, this is the problem that was presented in class. It says that you get a relationship over here for n's where n's a positive integer, and s should find the sum. Now, certainly you could write the sum down. It's not a long sum. It goes from 2021 to 2025. The problem is figuring out what the terms are. All right. So what I want to do is talk about the approach to the problem. The approach problem, it may seem difficulty, but the bottom line, approaching these problems over here is just getting a feel for what they're asking you to do. And they're asking you for this sum over here. So what I would do initially is just write it down. And certainly looking at it, let me just maybe make this a little bit smaller. Looking at it, I notice that it's going from 2021 to 2025. So I would just write down the top then. What do you get? 2021, 22, 23, 24, 25. That's not so bad to write down. I stop at 25. The bottom guy, what's that going to be? Well, if I put the 2021 minus 2020, I get A1, and then you get A2, you get A3, you get A4, you get A5, all right? Now, the problem now is figure out what those terms are, but there's not many terms at this point. If you look at the terms, there's only 1, 2, 3, 4, 5 terms, all right? So I will go to the abstraction, but before I do an abstraction, what I claim over here is that you probably want to start paying attention to what a problem solver would normally do, and you certainly have time. This is not a competitive exam, by the way. I will say this does come from a competitive problem set, and the competitive problem set, students are really under a great deal of pressure to finish a problem very quickly. And therein lies a big problem that students are faced with doing a problem incredibly quickly. I'm not very good at doing things quickly, and it takes my time, but there is this famous mathematician, I think he was at University of California, mathematician, and pretty bright guy. I mean, he certainly came up with a problem-solving approach. All right. So I just want to kind of read one of the quotes that this guy came up with. This is even fairly good students, when they've obtained the solution of the problem and writing it down neatly, which is a key word over here, a neat argument to it. I did write that down. They often shut their books and they look for something else. But I'm going to say, in doing that, they're missing an important opportunity, to instruct themselves about the structure of the problem. So a good teacher should understand and impress on his students the view that no problem, whatever you're doing, by the way, is completely exhausted. All right. So one of his approaches that Paulie would use in a problem like this over here is he would look at, basically, I wonder what numbers would look like in the problem. So what I want to do is go over here and talk about a problem that's fairly abstract. All right, so this problem is abstract over here. And what do I mean by abstract? If you look at it, this is an abstract thing. I don't know what those numbers are. So what I would do over here is kind of say, gee, well, I want to make it more concrete. And the way I would do that is, write down the relationship they've given me. Let me put out what I mean by that. They give me this relationship over here, and this is a pretty easy relationship to follow. It's recursive. You could say an plus 2 is equal to, this is still abstract, by the way. What's it going to equal to? 1 plus an plus 1 over an. It's fairly easy to solve. And this is what's known as a recursive formula. In other words, that this guy here is defined in terms of this over here. So what I tried to do was, say, look at a concrete example. So then someone says, well, wonder how you do that over there. I'd pick numbers that are pretty easy, by the way. And this is what Polly would also suggest. So I picked A1 to be 1, and I picked A2 to be 2. And this is the formula we just derived, by the way. Let me go back over that with you. That's right over here. That an plus 2 is equal to 1 plus an plus 1 over an. So I'm going to say, it's fairly easy to understand, you understand. And then someone says, I wonder what A3 is. I write it down. It's 1, right? I do see that in the formula. And then it's going to be, let's see, A3, I'd have to put down, let's see, that would be A2 then. Well, that's 2. I put that down. Divide by 1, because that's what AN is. A1, I mean. This would be 3. So let me write this down. Maybe I should have written this over here, be more clear about it. So A3, and I'll correct the notes for you. This is going to be 1 plus A2 over A1. And again, what's A2? A2 is 2. What's A1 is 1. So, I mean, a really simple computation. 1 plus 2 is 3, and 3 divided by 1 is 3. Then I put A4 down. What's that going to be? 1 plus A3 over A2. Well, I'm looking at it. It's 1 plus A3 is 3. A2 is 2. 1 plus 3 is 4. 4 divided by 2 is 2. Not so bad. Now, let's keep going. What's A5? I'm looking for a pattern, by the way. I'm hoping to see something that cycles. Then what do you get over here? 1 plus A4. What's A4? Well, A4 is 2. And then what I get? I divide by A3. What's A3? Well, that's 3. 1 plus 2 is 3. 3 divided by 3 is 1. I go to A6. What do I get there? 1 plus A5 over A4. What's A4? Is 2. What's 1 plus A5? Let's take a look at that. Maybe we should write that down too. 1 plus A5 over A4. What's A5? Well, it's 1. So 1 plus 1. What's A4? It's 2. 1 plus 1 is 2. 2 divided by 2. Oh, look at that. It's 1. What a nice, easy number. All right? Let's do A7. Just getting a feel for it. Very easy computation. 1 plus A6 over A5. Well, let's take a look at that. And let's see. 1 plus A6. We should write that down maybe. 1 plus A6 over A5. 1. What's A6? It's 1. What's A5? That's 1. Oh, that's 2. All right? So I'm starting to see like a pattern over here. And the pattern's going to be, I'm seeing 1, 2, 3, 2, 1, 1, 2. Now someone says, I wonder what the cycle is over there. I'm kind of looking at it, and I see this over here. I'm going to say it seems like it's repeating. Now, again, if you're not sure about that, you can keep doing it. So all I'm going to say over here is that I get a repeating pattern, and I want to follow it forward. And this is trouble for a lot of students, following things forward. I'm going to get my eraser out. I'm going to start to erase things now. Then I'm pretty sure I got a nice pattern. But again, if you don't see that, you can keep marching forward, and you'll eventually see that it just keeps repeating itself. It's recursive. You're kind of expecting this thing to be cyclic. So what I do now is kind of predict on it, and I want to point out that if you look at it, there is a predictable pattern to it, like A1, and if you look at it over here, I'm going to again let's just point out what the pattern is. You got something like this over here, repeats itself, keeps going and going and going and going, and I'm not saying you count there, but you start to realize that you could start to look at a pattern and say A1 produces this, A2 produces that, A3 produces that, and you kind of march your way forward, and you start to realize you can get these numbers, whoops, sorry about that. You can get these numbers over here. This is a concrete example of it, all right? So what do? I go back to the sum, and I write it down. I just did that in the beginning, by the way. I do my concrete example. What do I get over here? Let's take a look. But I got to correct this too. I just did copy paste over here. This is not really, maybe cross this out. All right, we'll go back to that later, by the way. So it just says the seed value can't be 0, because if you had 0, you have division by 0. So I just write the numbers down, and numbers, what I'm getting over here, it looks fairly simple, by the way. A1 is 1. Remember, that's your seed. Then A2, that was 2. Whoops, sorry about that. What did I get over here? Oh, you know what? I made a mistake in my notes over here. I gotta correct this over here. You're not going to see that when I copy this down, by the way. But let's write this down then. This equals A1 is 1. A2 is 2. Let's go back up here. I'm just copying these things over here. A3 is 3. A4, these were my C values, was 2. And let's see, A5 was 1. All right, let's do A 2021. That's 1. 2022 is 2. Then I get 3. I'm just copying this over here. I get a 2, and I get a 1. What do you get there? 1 plus 1 plus 1 plus 1 plus 1, which equals number 5. This is a concrete example, all right? What I want to do is go back over the abstraction, because doing a concrete example doesn't say I got it right, but this is where a lot of people are going to have some trouble. Let me get my eraser out again. And this is where a lot of students have trouble with this over here. But certainly I'm going to say that the best thing for you to do is, instead of using a concrete concept, use abstract. So I said A1 is equal to alpha. I do want to point out, though, that the alpha cannot be equal to 0, all right? And then I'm going to do the A2, and certainly, so what are you going to do over there? I'll just call it beta, all right? So beta, I'll put the beta down. I'm also going to say beta can't be equal to 0, all right? Then I start writing down what the formula says, and I do this every single time. I write down A3, I write down A4, I write down A5, I write down A6. And I get these expressions, by the way, just by plugging it in. You know, what are you plugging in? 1 plus A2 over A1. What's A2? It's beta. I kind of like divide it into 2 terms. Not essential, but you could do that. What's A4 going to be? It's 1 plus A3 over A2. Well, I write it down. What do? I look at A3, write this over here. I do some simple manipulations, by the way, and you get this stuff over here. Then I look at A5, I write that down. Oh, it's getting more difficult. I don't see a pattern. I see this over here. I'm starting to see something now that looks like it's getting simpler. And then I go to A6, and what do I get? I get this thing over here. By the way, I'm back to A1. So I'm getting a cycle now. I'm getting a cycle. I'm back over here now. All right, I'm getting a cycle. Again, you can keep repeating this over here, and you'll see this thing being cycled, cycled, cycled. So once I see a cycle over here, I can basically write it down again. And when I'm writing down this thing over here, I'm just writing the formula down again. I'm going to say that in the cycle over here, this is the cycle here, that this is repeating itself, that you can start to say, oh, gee, alpha equals alpha. That's A1 in 2021. I'm getting this from right over here, by the way. The next term is beta, whatever that beta is, not 0. And I keep moving through this over here. And this thing is just going to be whatever A3 is. No matter how complicated, it's going to be A3. It's going to be A4. It's cyclic. That's going to be A5. What do you get there? Same thing you got in the concrete case. 1 plus 1 plus 1 plus 1 plus 1, which can equal to 5. 1, 2, 3, 4, 5. Again, going back to Polya, Polya was very famous for taking abstract problems and making them concrete by taking some simple numerical examples. But nonetheless, after he did the numerical example, he'd have to go to an abstraction. And this is a good case of an abstraction over here. So what I'll do is I'll publish certainly this video. Hopefully you'll see the video if you're interested in the problem. But I'll also publish the notes, by the way. All right. I'll make some corrections in the notes as well, by the way. All right. Thank you for paying attention. I appreciate that.